again, the fourth method of factoring of solving is called complete the square, and we just said 25 is a perfect square because it has two factors that are the same. 5 times 5 gives us 25. Well, we then can say that x squared plus 6x plus 9 is a perfect square trinomial because it has two factors that are the same. X plus 3 times x plus 3, when you multiply and FOIL those together, we get x squared plus 6x plus 9. We are going to, in the next example, figure out how to create perfect square trinomials. So if we take a look at our back number is a perfect square. What's the square root of 9? 3, right? And 3 plus 3 gives us 6. When we're dealing with trinomials, and it's factorable, two numbers that multiply to give us 9 are 3, and the add to give us our middle, 6. Okay, so we're going to kind of use this concept to figure out how to create perfect square trinomials. And if you notice, the numbers we're adding and the numbers we're multiplying, they're all the same number. So we take a look at A. We want to make each of these trinomials a perfect square trinomial. So to figure out what value does C need to be for it to be a perfect square trinomial. So if we look at your middle, what number can I add to itself? We add to get the middle to get 10. 5, right? So to get the back number, multiply 5 by itself. What's 5 times 5? So C has to be 25. 5 plus 5 gives us 10. 5 times 5 gives us 25. So C would need to be 25 to be a perfect square trinomial. Well, what about B? What number can I add to itself to get 8? 4, right? So to get the back number, multiply it together. 4 times 4 gives us what? So C needs to be 16. And 4 plus 4 gives us our middle, 8. 4 times 4 will give us our back number, 16. Well, what about C? It's an odd number. How to figure that out? But what's kind of a shortcut way? What can we do to 10 to get 5? What? No. Divide by 2, right? Half of 10 is 5. Could we do the same thing to 8 to get 4? Yeah, right? 8 divided by 2 gives us 4. So, we're going to divide 3 by 2. And we divide by 3 by 2, we don't get a whole number. So we leave it at 3 over 2. 3 halves plus 3 halves gives us 3. So we're going to multiply that together to get our C. We're going to do 3 halves times 3 halves. When we multiply fractions, just multiply the top. 3 times 3 gives us what? And 2 times 2 gives us 4. So C would need to be 9/4 in order for that to be a perfect square trinomial. Same thing. 7, same kind of pattern, divide it by 2. We can't really divide it by 2, so we leave it as a fraction. Multiply it by itself to get C. What's 7 times 7? What's 2 times 2? So C would need to be 49/4 for that to be a perfect square. So the rule, when we're trying to make perfect square trinomials, would be to do what? What do we do with the middle number? Divide it by 2, and then do what? Square it. Multiply itself or square it. So the rule to get a perfect square trinomial is to divide, and our middle number we call B, by 2, then square it. That's the rule. Divide b by 2 and then square it. That gives you perfect square trinomial. This is a key thing we are going to use when we complete the square. That's what completing the square means. So the steps for completing the square, if you take a look below, are first you're going to rewrite the equation so that it looks like this. Okay? To do this, you're going to get the terms with the x on one side of the equation, and then the constant, or just the number, on the other. So everything with an x is on one side, everything without an x is on the other. We're not really going to deal with this today, but it's an important note that the a value, so the number in front of the x squared, has to be 1 in order to complete the square. We'll deal with what to do that, how to do that tomorrow, but you divide by that number. And again, we'll deal with examples tomorrow. We're not going to focus on those examples today. So we can kind of ignore step 2 today. Then, once you move the number over, divide by something if you need to, you're going to complete the square. We're going to do what we did above. So you're going to take the middle number, divide it by 2, and square it. And you're going to add that value to each side. After that, just do a little bit of factoring. You know, kind of a way to cheat when it comes to factoring in this step. Okay. Condense things down and solve. Okay. It seems overwhelming at first, but it's not that bad once you get the pattern down. Okay. Questions over that? No? Okay. So you flip it over to the back. We're going to solve this quadratic, number 1, by completing the square. So we're going to see how it compares when using the quadratic formula. So what's our first step when we complete the square? What do we have to do with the 3? Nope. What does step 1 say? Move it over by doing what? Subtract it. So we write it as x squared plus 8x. When you do this, don't jump ahead. Make sure you're following right along with what I'm doing. You're going to do plus a box. I'll make that a bigger box. Okay. Plus a box. And it's going to equal -3. What do you do to one side? You have to do to the other. There's a method to my math. Now, your next step, we don't need to divide anything. We're going to do that tomorrow. So we're going to jump into step 3. We're going to complete the square. Take your middle number. What's our middle number? 8. And we're going to divide by 2. Excuse me. What's half of 8? Thank you. 4. So we divide it by 2 and then square it. But we're not actually going to square it. Put the square there, but don't plug in 4 squared. Just leave it as 4 squared. Helps us with our next step. Questions so far? Make sure you pay attention. It's a positive 8, so it's going to be a positive 4. Now it's saying in our steps to factor, but I have a way to cheat a little bit. A shortcut method to factoring. When we factor, we end up with 2 parentheses. How many x's do we have in the front? Because it's x times x, right? We're just going to separate those x's. In each parenthesis, because the x squared is the front, so we get an x in the front. How many 4's do we have? 2, right? Because we'll only focus on the left side. We only have 2, right? Because it's 4 squared. 4 times 4 is 4 squared. Well, we can separate those 4's. Each parenthesis gets a 4. And they're positive 4, so each parenthesis is going to be a plus sign. Just a little shortcut there. Is equal to, plug that in your calculator. What's -3 plus 4 squared? 13. is what? X plus 4 squared. Condense it down, write it once and square it. Is equal to 13. Now we need to solve for x. We need to get rid of that square. Look at the opposite. What's the opposite of squaring? Square root. Square root. Square root. Cancels out that exponent, so you're just left with x plus 4. Really, really, really important. When you're solving an equation and you take the square root, you have to put a plus or minus sign. I'm going to show you why. So you have to write plus or minus. Can we take the square root of 13? Nope, so you leave it as radical 13. The reason why we have to put our plus or minus sign, let's look at a more simple example. Let's look at square root of 4. What is the square root of 4? 2, right? But guess what? Also negative 2. Because a perfect square is where you multiply the same number by itself. Well, 2 times 2 gives us what? 4. Negative 2 times negative 2, what does that give us? 4. So the square root of 2 is the positive version of that number and the negative version of that number. Really important to do that when you're solving. Okay? Because you're going to forget a whole answer if you don't put that. Okay? So the square root of 13 is the positive radical 3 and it's also the negative radical 3. Both. Okay? And then your final step is to move the 4 over. How are we going to move the 4 over? And when we do that, it just goes right in front of that plus or minus sign. Here's our answer. So it's whatever negative 4 plus radical 13 is, and it's whatever negative 4 minus radical 13 is. Yes. What? I was just showing you an example. That doesn't have anything to do with the problem. That was explaining why we have to put a plus or minus sign. It was just a helpful explanation. It doesn't have anything to do with the problem. Questions over that? So now we're going to see how it relates to using, I'm going to shrink this, I have room, to write the quadratic formula. So now we're going to use the quadratic formula to solve, and we should get the same exact answer that we get when we complete this one. Do you know how we got the quadratic formula? By completing this one. So I'm not going to do it unless you really want me to. The generic version of a quadratic, that, it did complete the square to that. And you get the quadratic formula. So that's where it came. So we should get the same exact answer when we do the quadratic formula to the same quadratic. Okay? So I'm going to fill out the skeleton of my formula. Label my A, my B, and my C. What is our A? 1. What's our B? And what's our C? 3. So we plug it in. A goes here, B, and C, A. Then clean it up. What does that 8 become? Negative, plus or minus, some radical, and the bottom 2 times 1 is 2. What do we get underneath our radical? 2. Little hint, we can simplify 52 because we're supposed to get the same answer. So we're going to keep going. What's the largest perfect square that can go into 52? 4. How many times? What's the square root of 4? What's left under a radical is 13. So we get 2 radical 13 in the top. Yes?
What about in some situations where you're trying to get the square root, you like trying to break it down, and then there's like a decimal.
What do you mean?
Like you put in your calculator like a number, and it doesn't give you a whole number, it just gives you like that.
Then you can't use that to simplify. You have to use a perfect square, and a perfect square has to go into it, and it has to give you a whole number.
Or if you can't find one,
Then you can't simplify it.
you just do it like that.
Yep. Then you just stop. Yep. Then you stop. Are we done? Little hint? No, so it has to be the same. So we have to check and see if we have parts. Is there a number that can go into 8, 2, and 2?
Yes.
Yeah. What is it?
2.
2. Negative 8 divided by 2 is? Plus or minus 2 divided by 2 is 1, and 2 divided by 2 is 1. So the ones you don't have to write, you get the same exact answer. Okay. So that's why we have the quadratic formula. So complete the square kind of came first in mathematics, and then someone was like, oh, how do you do complete the square? So the generic version of a quadratic is this formula. I just plug everything into the formula and it gives you the same. So I think it was meant to be a more efficient way of solving it. Which way do we like more? The new way or quadratic formula?
Quadratic formula.
This is so weird. This is like the first year I think students have said that.
Well,
In the years past, students hated the quadratic formula. They loved the, they loved. But they preferred the first method we did over quadratic formula. And I think because you guys have done pretty well with quadratic formula this year. But no, I think it's just complete the square. It's the same thing every time. Literally the same thing every time. Just different numbers. For quadratic formula, you have to think about it a little bit more. You have to simplify the radical and then simplify a fraction, and sometimes you don't, sometimes you do. Complete the square is pretty consistent. That's why students tend to like complete the square more, but I'm getting the consensus that this year we like quadratic formula. It's interesting how it goes year to year. But in the years past, like, complete the square all the way. Given a choice, they would use complete the square. So, interesting. All my classes, they said, overall, quadratic formula has been their preferred method. What if you could factor? Quadratic formula? Let's try this one. We're going to use complete the square. If you're told to use complete the square, you have to use complete the square. Now that we know all these different methods, you have to use what you're told. If you said, do any method that you would like, then you can pick your favorite. But they're telling you to use complete the square, so we have to. What's our first step? Move the 30 over to the other side. So we get x squared minus 10x plus a box, and you could go ahead and even square that box, is equal to negative 30 plus, again, box squared. Squared anyway, so let's do it right. Then we have to fill in those boxes. How do we fill in the box? Divide the middle by 2. Our middle is negative 10. What's half of negative 10? So it's negative 5 squared. We divided by 2, and then we squared it when we put it in the box. Then make our 2 parentheses. How do we fill in our parentheses? What are they going to look like? X is in the front. What's going to go in the back? Negative 5. We have 2 negative 5s. We divided a negative 10 by 2, so it's a negative 5. Negative 5 goes into the parentheses. Pay attention to that. That's the biggest thing I see. Not the end of the world if you do it, but it's not right. What's your question? Because we divide our middle, which is negative 10, by 2. And it gives us negative 5. So pay attention. If the middle number is negative, make it a negative. If the middle number is positive, make it a positive. Plug this in your calculator. Make sure you put parentheses around the negative side when you square it. Oh. Did it make 30? Yes, negative. No, negative 5. So then we are going to rewrite this. How can we write x minus 5 times x minus 5? And then when we solve, what do we need to do to both sides? We get x minus 5 equals, we took the square root, so what sign do we need? Plus or minus, because we took the square root. We have a negative underneath our radical, so what do we need to take out? An I. And the 5 underneath the radical becomes what? Positive. Can we simplify radical 5? Nope. So then we need to get x by itself. How are we going to get x by itself? And where's it going to go? Right in front. So it becomes x equals 5 plus or minus I radical 5. And there we go. And if you did this quadratic formula, you would get the same exact thing. Questions over that? One more. What's a little bit different about this one than the other one? Yeah, there's a number. The number's already been moved over for us. Don't move it back over. Leave it there. You just can go ahead and write in your boxes. X squared minus 4x plus a box squared is equal to 2 plus a box. How do we fill in our boxes? How did you get negative 2? Divide your middle by 2 and we get negative 2. And it's squared. So we squared our boxes. Then we write our parentheses. What's going to go inside of our parentheses? And negative 2. We have 2 x's. We split them up. We have 2 negative 2's. We split them up. Is equal to, plug that in your calculator. 2 plus negative 2 squared. Make sure you put parentheses around it. We get 6. How can we write x minus 2 times x minus 2? Good. Now that we condensed it down, what do we need to do to both sides? So that breaks the x minus 2 free. We took the square root, so what sign do we need? Can we simplify square root of 6? Nope. So then to get x by itself, what do we do with 2? You add it. And where's it going to go? Yep, right there. So we should get x equals 2 plus or minus radical 6. Questions over that? Same steps every single time. When you get the pattern down pretty well, a lot of students go from the top green step to the top first green line, and they jump right to the purple. Because every time it's a parenthesis square. And what's inside your parentheses is an x, and then whatever is inside your back parenthesis in your box. So we have a negative 2, so it's just going to be x minus 2 squared. equals whatever this is. So a lot of students, when you get the pattern down really well, go from green to purple. And that's okay. It's okay if you need her to write the orange step. I don't care. So a lot of students go from green step to purple step. And it's all. They just know what it's going to be. Because it's the same thing, just different. Questions over that? Alright, here's some practice. It's 3 problems.